Welcome again, Jason here, Rashawn here. For this project in AWS, we're going to host a website on Elastic Beanstalk, which will also launch two EC2 instances with some Elastic load balancers, which will give us as many or as little instances based on website load. The website will take an email address or email address inputs for a raffle that we're going to do within the company. The user will type an email inside the user input, and we'll use DynamoDB to collect all of those emails. We're also going to use CloudFront to invoke its content delivery capabilities to create a distribution on the Elastic load balancer to access the site from. If we wanted to, we could use Route 53 to attach it to a domain name, but we'll skip that step. I don't have a domain name. So anyway, first thing we're going to do here is create a table in DynamoDB. We like to use code around here, so we will go in the GUI, but we will also create it through Python. So all you have to do for this, we're going to have, give me a second here, we're going to have a DynamoDB table. The table name will be users. The partition key will be email, since we are going to take in emails on this site. And the key type will be string. No need for a sort key, default settings, and that's all you need to create the table. However, you can also create a DynamoDB table with Python, which you have right here. And it'll do the exact same thing. At the bottom here, we see table name, users, partition key, email, and partition key type will be S for string. So we will run this. We need an interpreter. I didn't think we needed. And after all that, the table should be there. Just take a look in a second here. And there it is. Table name users, partition key email of type string. So next up, what we're going to do is go into Elastic Beanstalk, and we're going to create an application. That's what we wanted to do. So we're going to give it a different name here, but we're going to call this, just for now, TCB test, because if we press next here, it's going to actually show up on the Elastic Beanstalk list. So we're going to put test there, and automatically you see the environment name has an env at the end of it. So we'll go down here, we'll choose a platform. We love Python around here, so we'll pick Python. We'll pick the latest supported 3.11 on Linux 2023, Amazon platform 4.1. Over here, it says sample app, existing version, and upload your code. We will upload code here, and the version label will be TCB conference version 01, but in this case we're going to put 08 because, again, this is only an example. We're going to do this through code in just a little bit. The S3 URL that we will need will come from here, and basically I'll show you what is in there right now. This application in the S3 buckets. It'll work with the CloudFront that we're going to use just a bit in a few minutes here, where we're going to take an email entry in the website that we will see in a bit. Preset, we want to go high availability with this one. We will click next, where we'll configure server access. we will want the AWS Elastic Beanstalk service role, and for the EC2 instance profile, we'll need the AWS Beanstalk EC2 role. Those will have to be created on your site. We'll take a look in a few seconds. The key pair, you can create a key pair or have something else that you already had. We have the Beanstalk key we'll access these EC2 instances with the Beanstalk key. So for the AWS Beanstalk service role, we'll go into IAM right here. We're not going to create it, but look at roles. You're obviously going to create a role, but I think we know how to do that already. We'll go to AWS Beanstalk service role, and what you will need for this role is the AWS Elastic Beanstalk Enhanced Health and Managed Updates Customer Role Policy. So we'll need both of those for that. And if we take a look at the other role that we'll need, it'll be the EC2 role. And for the Elastic Beanstalk EC2 role, we'll first of all need the Elastic Beanstalk multi-container Docker, the web tier, the worker tier, and we'll also need it to talk to the DynamoDB service as well, so we'll give that full access. Right, so we'll need one of these ARNs later, by the way, so we'll take a look at that in a second. But we go back here, we would press next here. And on step 3, choose your default VPC, which should already be there. We'll take that. For the instance settings, assign a public IP. If you don't take this, then it'll basically be private. You cannot access the instance through the internet. For the instance subnets, it should come with the VPC, or the default VPC should come with 6 subnets, so we'll take all of those as well. For database subnets, we're only using DynamoDB here, so it says if it's attached to Amazon RDS, then you would check these, but I don't think we need to do this here, so we'll skip over that, and we'll click Next. We'll set a volume for this, so SSD storage, 10 gigs is all we need for this lab. Then we'll go down, and for load balancers, we'll want 2 to 4 instances here. So we want a minimum of 2 EC2 instances, a maximum of 4. We'll keep this the same here. We want a T2 micro, still in the free tier. Keep this AMI. And for scaling triggers here, very important, we want to go to CPU utilization. Keep that on average. We need % here. And we need to switch the period to 1 minute and the breach duration to 1 minute. So basically it'll take a wellness check basically of the instances every minute to see if we pass a certain threshold here. And if it passes that threshold, then the breach duration also being 1 minute will also decide whether or not an extra instance is added or subtracted. So this is for CPU utilization here. So we want the max threshold to be, for this, 50%, lower threshold to be 40. So basically, if the threshold of CPU usage goes above 50%, then it will give us an extra EC2 instance. Scale up, just 1, scale down, -1, and it'll iterate between all of that. So basically, if after another minute, when we have 3, it's still above 50%, then we'll go to a 4th instance. Load balancer subnets will check all of these. And then we'll be good here. So we will go to next. Where All of these are all good, but there is an environment property that we do want here, so we want to add one, and that is for AWS region. And the value for that would be the availability zone that we're currently using, which would be US East 1. Just check that, and that would basically be it. However, again, we're going to do this through code. So that would be how to do it through the GUI, but we're going to do this through code. So we're going to go back to Elastic Beanstalk here, just showing you that there are multiple ways to do this. First of all, let's just take a look at applications here, and we'll just delete. We'll just delete that because we don't actually need it, and it'll eventually delete there. There we go. So now we're gonna go into Visual Studio Code, and it's all the same thing. Application name will be TCB Conference. You saw the environment name had the -e and v at the end. The version label, we'll call it source. Same link for the S3 URL. This just breaks down the S3 parts of the S3 bucket right here. The VPC ID that we had before and the subnet IDs. This is the platform that we talked about, Python 3.11. And the rest of this is what we also saw before. We've got the Beanstalk environment, the auto scaling on T2 Micro, the key pair that we'll need, the Beanstalk key, auto scaling here, 2 minimum, 4 max. We want CPU utilization, average %, threshold 50%, value 40% for lower, auto scaling trigger for period and breach duration 60 seconds. Some more stuff here for the Elastic Beanstalk. The service role, which is very important here. If you do this through code, I had a bit of an issue here, is you have to have the ARN correct here. So for the Elastic Beanstalk service role, this is the full ARN that would go into here. And some more with the load balancer. There's the environment or the region we talked about. Python path that was already there. For the EC2 VPC, the value at the top up here added to the variable. Same with the subnet IDs for the instance in the load balancer. Public IP address of the VPC, very important, has to be true. And same thing here, the ARN for the Elastic Beanstalk EC2 role has to be here, or this time it's under IAM, so no need for that. So now we're going to run this. And of course, it'll take a while to make code like that, but when you can automate Elastic Beanstalk instances like that, it'll be well worth it. So we'll go back, as we can see here at the bottom, no errors, and it created everything that we wanted. So we'll go back here, and we see that the TCB Conference app is here. And right now, it is launching the environment, and it'll show all of the events right here. And after a while, the health pending should turn to a green OK. So we'll wait until it's all set. All right, back perfect here. So we see the health is okay. We take a look at the events right here. Auto scaling group created, Cloud Watches involved. Was waiting for the EC2 instances to launch, which they both are here right now, although the second one here is initializing. Oh, it's all good. It created a proc file. The application is available at this URL. And the instance there was added. So we'll take a look and go into the site. And it is the voucher raffle, basically, is what we're simulating here. So we're going to type in an email. And it's going to be a random one. bob@swind.com. And Bob is registering. And we see there that the email has successfully registered. So now, how do we see, as the managers of this giveaway, or raffle rather, how do we see the emails that were added to the list? So we go back to DynamoDB here, and we click on the users table, and now we want to explore table items up here. It's going to fetch the items, and we see right there that bob@swind.com has been added to the list. If he was the only person that answered, he would win the prize. So now we're going to use CloudFront to use the content delivery side, utilize it over here. So what we're going to do this through code as well, but we're going to create a distribution. And all you need to do for this one is choose an origin domain, which will be the only Elastic load balancer on this list. And if you were to use the GUI when doing this, you would switch the protocol here to HTTP. Try that again. Protocol to HTTP only. So see the name of the domain right here, the original domain, origin domain. And the only other thing to, or one of the only few things to change here, is allowed HTTP methods. You'd have get, head, options, put, post, patch, and delete. We will leave that unchecked. Now we go down, cache key and origin requests. Caching optimizes what we want here. And then web application firewall, you want to enable security protections, standard for a website. So again, you can do that through the GUI. However, we will do it through code. Of course, always loving that. So we'll take the Beanstalk project right here. We have a CloudFront Python script right here. What we're going to do is copy this domain, and we're going to put it in the area where it wants the origin domain right here. So again, it does the very same thing. Little comment right here, CloudFront distribution for Elastic Load Balancer. It'll be HTTP only. As we showed back here, the items here, get, head, options, put, post, patch, delete. And then we will run this file. It says that the CloudFront distribution has been created. So we will go back in the CloudFront, and it is the top one right here. It is currently deploying, so we won't be able to go to the domain name, which is right here, until it's finished deploying. We'll take a look when it has. All right, so we're back. That took about 4 to 5 minutes there. As you can see, last modified shows that it is enabled. All you got to do is click on refresh a few times just to make sure that it's all good. So we're going to go to this site right here, which is the same site, this time on CloudFront. We're going to have a different email here. Imagine that LeBron wants to do this giveaway. So LeBron at Lakers.com, for example. I wonder if they give players email addresses. But there we go, registered successfully. We'll go back into the DynamoDB table, refresh, and we see that LeBron is now on the list. So now we go back to Elastic Beanstalk right here, and we can do many things. There are a lot of tabs over here. The instance held to these two instances right here, both obviously are okay. Let's see, no logs to display here, at least not for now. You can also monitor your instances as well, just to see what's going on. We'll put some alarms in a little bit, and the rest is there. So now we are going to SSH into one of these two EC2 instances, and we're going to do a little bit of stress testing right here. So we'll take the public IP of one of these two EC2 instances. We will go into VS Code right here, and we will SSH into this email address, or this IP address, excuse me, with the key pair right here. Press yes. And now we are in, and what we're going to do to stress test this right here, because we're trying to get an extra EC2 instance, so we will do... Okay, I missed the point here. So first, before we do the stress test, we have to install the stress program, obviously. So we'll do sudo, go up here a little bit, sudo yum install stress -y, and the package is all there. So now we will stress test right here, and it'll stress test all 4 CPU units. We're also going to do, we're going to SSH another terminal in here and SSH into this as well. And we're going to see, it's basically like Task Manager. What we're going to see here, what are the tasks that are using the most CPU. Going to do the command top to see here. As you can see here, it's being stress tested. The CPU usage is at 100% right now, basically. And I believe it has spawned a new instance right here, or it's trying to. Let's take a look to see if it'll do it here. Actually, in about a minute it will, so pause the video again, and once we get to a third instance, I'll come back. Actually, before we do that, we'll go back into Elastic Beanstalk right here, and we see that there is a warning. Environment health has transitioned from OK to warning. 1 of 2 instances are impacted. See health for details. This is obviously because one of the 2 EC2 instances is pegged at 100%. So we can take a look at health for details, and it says that one of the 2 instances has degraded, and it is set to 100% of CPU usage. So at this moment, it should be adding another EC2 instance just any second now, as I take a look at more things that I'm interested in here. All right, so as we can see here, as the EC2 instance continues to get stressed, we see a third EC2 instance come up, and in a little bit it will be running and it'll be all good. I'm not gonna wait for that one this time, and we'll just do one more email actually, just to make sure that despite all of the load, we can still add an email to the DynamoDB table. So we'll do ken at grappler.net, register, take a look at the DynamoDB table, and there it is. So in this hands-on, in this lab, we use DynamoDB, EC2, Elastic Beanstalk, IAM, CloudFront, probably more that I've forgotten in order to host a website and get a list of emails to conduct our raffle. So it's Jason, Rashawn. We'll see you for the next lab. Thanks for watching and listening.